to, it'll probably be Monday of next week that I'll assign it. So we've got, so we're doing the this is the last day of the statistics stuff. There's a couple more statisticky things that I'm just leaving for the tutorials. They tend not to be things that people use in their projects. Bless you, bless you.
Thank you.
And so I just leave them for the it's the regression analysis. I have 2 really short tutorials in there on regression, which is really fun and fairly straightforward. The thing about regression analysis is often the difficulty of getting the data together in the first place. So that's really the challenge there. So this is the last of the spatial stats tools that we'll use. Will be today, and then starting on Wednesday, we're going to do the interpolation and data splitting stuff, and that's the last sort of big chunk of instruction that we have for the class, and that's the last piece you need to know for your problem set. So I'll be assigning that soon, and problem set 2 will include interpolation doodads for you to do, and it will also include some spatial stat stuff that you'll do on your own. So I'll provide you with other data sets. I have a couple things in the wings. I have one that is a Walmart data set looking at the expansion of Walmart over time, and the other is I've got some national gun statistics, which I'm thinking about framing a question for you around for spatial stats. So you'll have those pieces. We'll do those going forward. It'll probably be 3 classes usually on the interpolation. Once we're done with interpolation, then we get to do fun things, or sometimes they're more fun than others. But the idea is I'll look at the projects. You guys should have your projects well thought out by then. And so I'll look at the projects and see what you guys have going on, and I will frame whatever instruction I do from there forward. Usually the last couple of weeks, I don't even really lecture at all. We have opportunities for questions. Often I'll just stop the video, I'll record whatever questions I answer, and then let you guys work on your own. And I can stay on, Ernie, if you're on a call, and we can talk. So that's, and we're actually doing pretty well. Usually I'm further behind than this, and it's amazing that I'm not. I have no idea considering everything that's been happening. So we're in pretty good shape to make sure that we get to the point where we'll have the interpolation stuff done and have a good couple weeks at the end before classes end for you to work on your stuff. Okay, so before I forget, I have a code for you. So let me share my screen and show you my code. And my code is, got it right here, 1660. So the code is 1660, and the thingamabobber has been posted. And Andrew just left the room, so. Okay, so that's all there. 1660 is the code, and what you're going to need today is so it's a pretty old tutorial that I love, and it has a really great data set, and it's perfect for showing this hotspot analysis. This one more set of tools that are really, really useful and very easy to use. And it's the kind of thing that I end out using. Crime data is probably the most common application, but it's really great for doing some basic spatial statistics on incidents of any kind. And so you're going to find that on this week's page. Yes?
Is there also data I might need for since I'm on your computers?
No, you should not need any data other than the data that we're going to get that we're going to download with this thing.
Okay.
Yep.
So we're going to go with that in a bit.
Yep, exactly. So week 11 is this week. And if you go to, right now on the page, it's listed as click here to download the crime tutorial and data. And it brings you to this page and you just hit download, and it is a zip file. So go ahead and put it in your GIS 330 folder. I'm going to put it in a new folder called crime. And I'll unzip it. And once you get in there, you'll see there's an MPK, which you should open. You can just double click it and it will open in ArcGIS. And then there's also this hotspot analysis tutorial. One of the reasons I don't just assign it as a tutorial that you do in class, it really should be a tutorial. And I think there might even be a tutorial that uses GEDIS analysis in it. But it's not. It's just in this, but it's written for 10.1, version 10.1 of the software. So it's really too old to assign. The differences are too great. You need some water. So while you guys are getting that all going, once it's up and running, I'm going to get my water. What happened to Andrew?
Our time has gotten slower and slower.
Yeah, and you know, I am really, really hoping that they are going to give us new computers. That I don't have money for.
I'll probably do it after a couple years if you guys pay.
Yeah, right.
So we don't continue.
Right. Well, it used to be 3 years, but they informed me this year that it's now 4, and I was like, that's not cool for this lab. So there you are. You all right?
Yeah, and pulling those.
Oh. All right. 1660 is the code. And if you go to this week's page,
It can be right there.
Yep, it's click here to download the crime tutorial and data. And there are 2 things in there you will need, which are the instructions and an MXD file, an MPK file. So when the MPK opens, it looks like this. I haven't done this in a while, so I'll be referring to the tutorial myself, just because it's like that. So once we have the data there, take a minute and explore the data a little bit so that you understand what each of the data sets, more or less anyway, it won't all make sense, what it means. And I'll explain it a little bit as well. So this is 911 call data. The response stations are various types of basically police stations. So I think there's, looks like engine, truck, I don't know what L brush, H brush is, tender squad, volunteers. So it's all, I think it's all emergency calls. And then if you look at the attribute table for the calls layer, you'll see call types. So there's various crime types.
Can't get the pin.
I can't hear you.
I don't know why I can't get this pin over here.
So to pin something, so let's say your toolbox is floating, you click this bar up here and then you put your pointer on the blue arrow and then let go.
Speaking of calls, did you hear about that woman who worked at a call center and she just kept hanging up on people? It was,
No.
I forgot where it was,
Wow.
but yeah, she would basically just, she would
just hang up on people who
Yeah,
called
like-
for emergencies.
yeah, like, I don't have time to deal with this, and just hang up on them.
Wow.
She got charged.
Horrible.
I think she got charged with like misusing 911 and a few other things.
Wow. So anyway, so there's all these different types of things that people are calling emergency for, and they are scattered around the city. I forget which city it is. But they're scattered around whatever this city is. I think it's Seattle. Let's see. It'll remind me if I go like this. Portland, Oregon. I know it's in the Northwest. Okay, so once you open it, you'll see that there's all these different 911 calls. And the first job that we have is that we need to figure out if our data is projected. Why? We're going to analyze hotspots using a different way than we used the other day when we were doing cluster analysis. Why do we care whether our data is projected? This is really crucial.
Because it preserving the area and the distance, so that way we can tell
Good.
which calls are actually inside which district.
Okay, so topological relationships like containment won't change with projection, but you hit it on the head with distance and area, right? So measuring distance, that's really crucial to understanding hotspots. How far those spots are from each other, you know, how far each call is from another one is really crucial. So you always want to project your data. So how do you know what the projection of the data is now? How can you tell?
Layers, projection, like properties.
Mm-hmm. Okay, so if you go like this, you'll tell what the projection of the data frame is, and it's this state plane, Oregon state plane projection. Are the layers in the same projection? And how would we know about the layers?
You have to do that thing.
You got to do a thing.
Yeah, I forgot
With
the
the
thing.
buttons,
With the buttons, you click something.
The thing we did in our tool where we did the
Okay, so we are going to do something with
See?
projections,
yeah,
but first I want to find out. I'm going to right click on the calls layer and go to properties. Then I'm going to go to the source tab. And what do I notice there? What's going on there?
unprojected.
It is unprojected. How do we know?
It says featured class calls unprojected at the top.
Oh, let's see. Does it say? Yep. Calls well, that's the name of the layer. But if the layer were just called calls,
There's no Z coordinates or anything.
yeah, even that. There's something right here, what I'm selecting right here. Geographic coordinate system. What is this? GCS, WGS 84 mean? That's the defined projection.
Oh, it's not the same as the layers.
That is the same as the layer. So that's the projection defined for the layer. GCS is short for Geographic Coordinate System. WGS 84 is the datum and geoid, right? That's what that refers to. And GCS is Geographic Coordinate System, meaning that's all that's defined as its projection. It's not projected. And so we want our data to be projected. And actually what's weird is the map has a different projection than the one recommended by the tutorial. I guess we'll use the one the tutorial uses, and I have a reason for wanting to do that. So what we're going to do is we're going to reproject this data. This is different from changing the definition. The definition is correct for the data as it is. We want to actually reproject the data so that it's saved in a whole other projection. And that means that it will, for our eye, appear in the same place, but it means that the coordinates on which the calculations are made will be different. And so to change the projection, what tool do I need? Take a guess at what tool I need. Doo-dee-doo. I need a particular tool. First of all, got an idea of which toolbox it will be in? One way to find is to do a search for the word project or projection or something.
Spatial analyst.
It's not going to be under spatial analyst. So if I search for the word project, I'll find the projections tool set, although that's not the tool set I want. Anyway, let me show you. So if I go to data management tools, projections and transformations, it's the project tool, right? So that's when you want to change the projection. We'll use the project tool. So I'm going to double click that and open it. I'm going to bring my calls layer in. And I'm going to put the output in my crime folder. And I'll call it calls project. Now the output coordinate system, right now it's in that WGS 84. I need to change that. So I'm going to hit this little browsey button right here. And do I want a geographic or projected?
Projected.
Good. I want it to be projected. And the one I want is similar to the, I'm going to use the one they suggest. It's going to be UTM, NAD 83, zone 10N. So that's the Portland UTM zone.
Can you show me where the tool is again? I was like,
Yep.
my toolbox in the way, and then
I had to go back. Yep. So the toolbox, no problem. The toolbox is under Arc Toolbox.
I got that. I got it back up. I just missed the exact part where the tool.
Oh, okay. Projections and transformations. And it's project.
No, but what is it? Which toolbox is it?
Oh, data management. Sorry.
No, it's okay. I was just like,
So yeah, Arc Toolbox, data management tools,
okay.
projections and transformations, project.
Sorry, that's all.
That's all right.
I know that part.
Calls, and this is going to be calls project. And the output coordinate system, again, is going to be projected UTM. This should be relatively familiar. NAD 83, zone 10N. And I want to show you also that automatically it detects that the geoid and datum and the coordinate system itself for the old projection was WGS84. For the new one, that's going to be NAD83. And so it needs both a reprojection and a transformation. And so it automatically detects which transformation you need. It used to be you had to know. So this is way better. So once that looks like this, click OK and let it run. And it's pretty quick. Shouldn't take long at all with point data with just a few hundred points. And it does not add it automatically to your map for some reason. So you have to add it yourself. That's the standard thing. So you want to bring that in. And then you want to do the same thing to the response stations. So you can go right back to the results tab and just double click project or just open the project tool again. If you do the results tab, you can bring the response stations in and just change the name of the output. Response.
Mine's taking one.
Yeah, might not be
I
too.
thought I went through the analysis, but it was on the map.
Yeah, if it's done, it won't add it to the map. So you have to go back into your catalog wherever you put it and drag it into your map. So it will add it. I don't know why it does that, but it's true. And I'm gonna, just to be sure I don't use the wrong one, once I have my projected layers, I'm gonna remove the old ones and I'll symbolize things so that I can see what I'm looking at here. And they're not showing up. Oh, it's weird. Did I have one selected somehow? I did. I had selected one by mistake. All right. Let me get that back. Response stations.
Oh, yours.
I'm sorry?
What happened to yours? Did ArcMap crash?
Mine? No, I had some features selected when I did the, in fact, I can show you a little trick. Error executing function failed to execute. So Ernie, that's the most helpful possible error message. So chances are pretty good you've got a couple of possible things. One is that the data are, in fact, I'm going to show you an alternative way to do what I'm going to do. I'm going to show you an alternate way. So here are my response stations, right? My oops, wait, where am I? I'm lost now. There we go. This is where I want to be. Okay, so here are my response stations, right? And I need to reproject them. I already did project the calls. Remember, my map is in some other projection. I'm going to change the projection that my map is in to match the one that I like. Let's all do that. Let's change our map projection to match the one that the calls layer is in. So I'm going to right click on the word layers and choose properties. And this is an alternate way to do this process, Ernie. So sit tight and I'll show you. And I'm going to change it from projected. Instead of state plane, I'm going to use UTM NAD 83 zone 10N. So again, right click on the word layers, choose properties, and then scroll all the way up. And then under projected, you can collapse state plane and expand UTM, expand NAD 83, and select 10N. It'll take a sec and it will regenerate. So you got it as in it worked eventually, or got it as in got the other projection? So now I've got this response stations. I need to reproject them. Another way to do it is, now that I've got my map in the projection that I want, I'm going to right click on these response stations and choose data, export data. And right here, I can tell it to use the same coordinate system as the data frame. So the same coordinate system as the data frame, and export it. And
Can you separate the response stations from the calls though?
you have to expand. You don't need to. Just right click on the word response stations. There you go. Data, export data. Put this in crime, and this will be response stations project. I'm going to save this over, the one that I messed up, and click OK. And now it will have the right projection. Ta-da! And I can remove the old one, and I can reproject the new one. I mean, I re-symbolize the new one so it does something fun. There they are. Although I still don't like them. I want something else.
I couldn't find the symbol they used. I ended up using a symbol for police.
Then export this layer's source data?
Nope. It's, see, the data frame. Remember, we changed the projection of the data frame. Yep.
Features, all features.
All features, yep. And then save it to your folder.
Add to the map?
Yep. There, I'll use these. This will be good. And there are my response stations. Ta-da!
Make sure you put your calls above your response, because there's actually a few that get blocked by the station. I just found.
Ah, yeah, there we go. And they have theirs over on top too. Great, great, great. Okay, everybody's with me, right? Okay. Okay, so now we have our data. So remember how when we were working with
John Snow.
John Snow, thank you, John Snow. The dots were already numbers of deaths at each address, right? But each one of these dots, and some of them are at the same, multiples are at the same addresses in many cases. Each one of these dots is, so here I just clicked on an address and it has two calls at the same address represented by two separate dots, which are right on top of each other. Right, so at that address, there are two calls right on top of each other with the same dot, right? And so right now it's just a cloud of dots. What we want to be able to do is gather the data into it's called aggregation, aggregate the data into groups. We can do things like use a spatial join and a polygon and join. So like if you had a neighborhood polygon layer, which we don't in this case, but a neighborhood polygon layer, you could collect all of them by doing a spatial join, and there'd be a count number, a count field after the spatial join. You can also create a tool. There's a tool called Create Fishnet, and you can make a grid with boxes of a particular size, and then determine, maybe we'll do that if we have some time, and then determine how many, do a spatial join with those, and determine how many dots are inside each one. But instead, for now, we're going to use a different tool. And in order to use that tool, we need to make a copy. It actually works with the same layer. So we need to make a copy of the calls layer. So to do that, just right-click on the word calls, on the calls project layer, and choose data, export data. And I forgot we were going to do this. We could have done this with the original layer and saved it with the data frames. It doesn't matter now. The data frame and the source layer have the same projection, but we're going to call it copy calls. And say yes and add it to the map.
The data frame again?
Yep, it actually doesn't matter now which one you select from data frame or source data. And there's the copy. And now we're going to use a tool called Integrate. And Integrate is under data management. I'm going to search. I don't remember what tool set it's in. So I'm just going to search for Integrate. And it's just a feature class tool. I'm going to choose Integrate, and I'll show you what the tool does. Oh, I thought I had a diagram, but I guess maybe it doesn't. Let me see. Oh, yeah, it does. Okay, so Integrate it's used for a variety of things. In this case,
could you put it up?
It's going to take XY points, all our points, and we're going to say, okay, search. And we're going to tell it search within 30 feet. So any points that are within 30 feet of one another, turn them into one point. Put them all into one pile. And then we're going to collect them. Okay, so it's going to take the points and snap them so they're all stacked up on one another as long as they're within 30 feet. So that's what we're going to do. We're going to pull in copy calls. The XY tolerance is going to be 30, and the unit will be feet. So copy calls is the input feature. The XY tolerance is 30, and the unit is feet. And you run it, and it's pretty quick. So while that's, it's all run. So areas where there are lots of points, if I'm looking at, there we go. So here's a group of points that were all grouped together, right? So there were points within 30 feet here. And so it's turned them into one pile of points in between. Another way to do it would be to use a larger data set. I mean, a larger, sorry, XY tolerance. What are some considerations that we might use when we choose an XY tolerance?
How large the area you're working with is?
Yeah, so how large the area is. You wouldn't want to have, like if your area is 1 mile square, you wouldn't want to have your XY tolerance be, say, half a mile or a quarter mile, right? You don't only end out with, 4 points. That would be suboptimal. The other thing is how precise the data is, right? So if your if your data is collected with a GPS that can only get you within 100 feet, there's no point having points that are more than 100 feet apart, right? Because the actual ability of the unit that you use to collect it can't be that precise. So, so those are various considerations. We're just using the 30 feet that they suggested in this tutorial. And now we're going to, now that all of our points are stacked up so that points within 30 feet of each other are all on top of each other now, we're going to do something called collect events, so that we'll find out where big piles of points are versus small piles of points. So, oh, right, one other thing, I don't think they say this, but I have run into this in crime mapping before. One of the things about crimes that has to do with this, how you aggregate and how you set your XY tolerance, is where would somebody, how far away would somebody be to be the person calling? And it's entirely likely that if someone's next door, they may be making the call. So you might have clusters around an individual house, and the person in the house, of course, might call, and any of their neighbors. And usually in a dense city like this, that might be 30 feet. In a place like Machias, it may be more like 100 or 200. Out in the middle of nowhere, it might be half a mile, right? It could be really far. So really, those sorts of scalar questions are what you want to think about. Okay, so the next tool we're going to use is collect events. And this is where we get now to our spatial stats tools. So we're going to go to the toolbox, and this time we're going to go back to our spatial statistics tools. And it is another mapping class. No, it's utility, I think. Sorry. Yes. It's utility called, so it's under utilities, called collect events. So spatial statistics, utilities, collect events. And open that sucker and bring in your copy calls layer as the input. And the output is going to be called, what do they call it? Aggregated calls. And I've seen people, incidentally, Ernie, this might interest you, I've seen people use this with sighting data as well for animals. Sampling data, if you, that's usually done with a fishnet, probably both literally with a physical fishnet in some cases, but also with a polygon fishnet, where you have sampling in a, sometimes it's random sampling or random stratified or whatever, and you collect the events within within those polygons of, you know, the occurrence of a particular species or what have you. Anyway, okay, so there they are, and they come in automatically with this field. So if we open the attribute table for the new aggregated calls layer, we'll see that it's added this I count field. And it's kind of interesting. I hate the default color. Feel free to change the default color. I'm going to sort that column descending. So somewhere here is a call that has 25, is that house that has 25 calls, right? There it is. That's a lot. I'm going to change this color because it's just too awful. I'm going to click template and change it to like red or something. That's better. I don't like flesh color on my map generally.
I wasn't thinking that, but now that just makes it even more.
I just don't appreciate flesh colors on my map. It just doesn't ever work for me. There, maybe I'll make it darker. There. Okay, I'm liking that. Okay, so now that we've got a layer that shows areas, shows individual, you know, pretty small areas with higher densities of calls, we can run a hotspot analysis. So we're going to use a different type of way of analyzing patterns and clusters called GIS ORD. So we're going to use the hotspot analysis tool, and there's a new one created since then, since this was done. So we might have to go from, I'm sorry? That's the thing. So it's going to be in the mapping clusters tool. And let's start with the original one. And the original one was the one they used because the optimized one wasn't invented yet. So, okay. Oh, I see what they're doing. Okay, I was like, why didn't they figure out the distance band? Okay, so we just want to open this tool.
Can you take the video's lagging a bit?
It is?
Yeah. Yeah, you have 2 mount. No, try again. Okay, it's working fine now.
Oh, okay.
For a second.
So,
Lagging quite far.
so they just really want you to look at this tool. We can start setting it up, and they have in the tutorial here that I'm looking at, they have you set it up with the aggregated calls as the input feature. The input field is that aggregated I count field, right? So that's where the numbers are. The output is going to be call hotspot. And conceptualization, let's see, okay, here we go. So the conceptualization, they want us to use fixed distance band. And so what this refers to, as you can see, it says this specifies how spatial relationships among features are defined. And there are a few different options here. We'll go over what inverse distance weighted means. We're not going to talk about that today. What we're going to use is a fixed distance band. And there's also a zone of indifference, so a fixed critical distance, which will only make sense after I explain the fixed distance band. So this is what we're going to use to conceptualize it. And what this is saying is, it's saying it's only going to analyze hot spots based on what's nearby. And it's not going to do things like give greater weight or what's nearby within a buffer, like a fixed distance. So it's going to say, okay, if points in an area have lots of other incidents of calls near them and lots of groups of high values near them, then that will be regarded as high, but it's not going to make more closer calls more important and farther close calls less important, right? So it's not going to base it on a more nuanced conceptualization of spatial autocorrelation. Okay? Near things are more related than distant things. It's not biased, exactly. It's not weighted or biased, exactly. So for right now, it's just We're just saying, okay, just regard points that are nearby in a particular distance. And so what you choose here, you can choose based on things that you know about your data. And it's also possible to do an analysis, and that is what we're going to do. And we're going to actually use a tool for that I almost never use, but we'll try it. We'll give it a try. Anyway, so here's how it often works. So for example, when I used this tool and similar tools to do spatial statistics on whale movements. So it was movements of whales within feeding areas, feeding aggregations in a particular area. So I was looking for clusters and hotspots in feeding activity. And I knew that that there was a relationship between, so I knew the relative size of not only the feeding areas themselves, which is basically like our neighborhoods here, but also I knew how far a whale would move after watching how they feed and how they move, how they would move to begin a new feeding bout, typically when they're feeding within an area. And so I knew what that distance was. And so I knew that my fixed distance, my threshold for comparing points would be determined by that distance. So that's something I knew about the data. And I could just say, this is what the distance should be. Try it. Maybe it wasn't quite right. Make it bigger or smaller. Try it again. And so if we want to find these hotspots in our call data, we need to know then what that kind of relationship is. But we might not really know what that is. So what we might need to do instead is to use some tools to find an appropriate scale of analysis. And so hopefully we still have this. We're going to use this tool. I'm going to minimize the hotspot analysis, just leave it minimized for a sec. And we're going to go to the toolbox for another tool. And I think this is modeling spatial, no, it's analyzing patterns. Yes, and it's still there. It's called incremental spatial autocorrelation. And what it will do is it will, huh?
I have it right here.
Okay, good, great. So incremental spatial autocorrelation, if you look down here, what we're looking for is measure spatial autocorrelation, right? How tightly correlated near things are to one another for a series of distances, and optionally creates a line graph of those distances and their corresponding z-scores. Z-score is, oh yeah, it reflects the intensity of spatial clustering, and statistically significant peak z-scores indicate distances where spatial processes promoting clustering are most pronounced. It used to be that you just get numbers and that was a pain in the butt. Now it gives you a graph. So here's what we're going to do. We're going to bring in our aggregated calls. The input field is going to be, of course, our I count field. The number of distance bands we'll leave at 10. And then for all the rest of it, we'll leave it as the default. We do want to, we don't need a table, but we do want a file. So I'm going to click right here under the output report file and click browse. And I'm going to go to my crime folder and I'm going to call it SA for spatial autocorrelation report.
Where do you
I just put it in my crime folder. Yep. So input is aggregated calls. Input field is I count. Number of distance bands is 10. Euclidean distance is fine. Everything's default except the output report file is going to go somewhere where you can find it and give it a name. that you can remember. Then I'll click OK, and I'll let that run. This one does take a minute. Spatial autocorrelation requires the machine to take every point and measure its distance to every other point within a certain distance band, and it has to do that 10 times because we have 10 different distance bands. So it's taking the distances, and I think it initially takes all distances between all points and then chooses the 10 numbers. Any tool that doesn't produce a layer will give you an output like it has a problem, right? It will pop up with this. You can click on it, and it will give you a bunch of things. This is a table. This is a summary of its results. But what's even better is we have the output file. I don't know if it gives us, yeah, it gives us the place where we can find it. But so if you forget, which happens a lot, so if you forget where you put it, you can go find it. But if you go to that file, there's my SA report. I'm going to open it. And it marks the peaks, and it also notes if they're significant. And those are there are two peaks in both of that are both significant. And so what these indicate here are distance bands where spatial autocorrelation was significant. In other words, there's an observable, statistically significant phenomenon of spatial autocorrelation occurring in the data if you use a fixed distance band of that distance. And so you can see what those distances are. And in fact, we should be able to get the actual numbers. They're either in the report or in the, here we go, first peak and max peak. So the first peak, that's this one, just over 1,400 meters. And the max peak, that's this one right here. It also should give us a z-score, and the z-score is slightly higher for the maximum peak. I expect that's what, I forget if they want us to use the first or the max. Looks like they want us to use the first. So the first peak is at about 1,400 meters. So let's use that as our distance band. Now we can go back to ArcGIS. And we've got the hotspot analysis tool still open. If you don't know where it is, wave your pointer down on the taskbar, and it should be one of the options there. And now we know what to use as our distance band or threshold distance. And that's going to be 1,400. I usually use the actual specific number.
So how do I open that back up there?
So wave your pointer down here where on ArcGIS, see right there, on ArcGIS, and then click. That's it. Is it the get a sword one?
Yeah.
Yep.
The fact that it puts the numbers on the right-hand side is annoying.
It's so annoying, yeah, because you can't tell that you put anything there.
Yeah, I was like, wait, it's not going in.
Yeah. And then it's there 4 times, 1,400, 1,400, 1,400.
Yes.
Yeah, I've done that totally. Okay, and then we're going to go ahead and run this analysis with the settings like this. Click OK. It takes a minute. Again, it's doing another spatial autocorrelation. It's called a semivariance model. There we go. And so it comes in with the symbology automatically showing hot and cold areas. And so we can see, I'm going to turn off all the other layers so I can see everything here. There are areas that are not particularly having low counts, and those are indicated by the gray. And then there are areas that are cold, meaning they're clusters of low values. There are groups of houses that have very few calls. And then right in here in this downtown area are clusters of areas that have high calls. They're in areas with high calls.
So I'm guessing suburbia that's a suburb over there where there's less calls.
Yeah, I think it is probably a wealthier neighborhood, that sort of thing, where things burn down and get stolen and or
Seems like
damaged
the
less.
station, right? Well, one of them in the right spot. The cardinal who's right in center of where it's all hot.
Yep. Yep. And interesting too that the response stations seem to be, at least two of them are situated right in a place where they're needed.
And the other one's
Yep.
smaller one.
And it probably serves this whole area out here. Okay. And so it gives a value for every feature on your layer. And it's, let's see. And we used to, I'm going to look at something here. Give me a sec, because this operates in a different way. Messages. Yep, okay, I guess it doesn't give me, fine, never mind. Okay, it used to give me more information, but maybe I'm thinking of another get a sword tool. Okay, so the symbology is based on its bin about whether it's in a hotspot or not, and how confident they are of the hotspot designation, right? Which is one of the statistical things that you get. The statistics that you get here. So the GI bin is the confidence p-value. Forget what GI score. GI score and p-value are, one is the measure of the significance of spatial autocorrelation and the p-value of that significance. And so and so wherever, so if I take the p-values, for example, and sort them ascending, you'll see that all the threes and all the negative threes, right, have, threes and negative threes have high confidence, right, high statistical significance, but their z-scores are positive or negative, right? So here's, for instance, one point where I've got, it's in the GI -3 bin, meaning it's very competent, has a very, very low p-value, meaning it's very statistically significant, and it has a high z-score, meaning high spatial autocorrelation, and it's negative. So it's high spatial autocorrelation of negative values.
So that means that that's an area where it would be very close to a not significant if it's a high concentration of.
So it's right, it's a high concentration of low values, right? So it's a high concentration of very few or no calls, right? Whereas right above it here, I've got one that has a very high z-score and a very low p-value, meaning high confidence. It's positive, meaning it's high values, It's a cluster, and it's in a cluster of high call frequency.
Bring me back to
Stats, yep. If you've taken stats, this is familiar to you. It's super useful though, because it allowed us to get thousands and thousands of dots and turn them into things that make sense, right?
All right. All right, here's your hotspots.
Yes, exactly. And all of a sudden, you know, you go to town meeting and you put this thing up, people understand what they're looking at. And behind it, you have statistical significance, right? Okay, so we're going to do one more thing, and this will be a good sort of stepping stone into what we're going to do next with interpolation, which is we're going to take our aggregated data and we're going to use the z-score specifically with the positives and negatives, and we're going to visualize the positives and negatives, negative z-scores, the clustering, right? High and low clustering, hot and cold, as a raster surface. And to do that, we're going to use a spatial analyst tool. So before we start, make sure that spatial analyst is turned on. So just to be sure, click Customize, Extensions. So Customize, Extensions. Jen. Click Customize, Extensions. And make sure Spatial Analyst is checked. And I knew yours wouldn't be because nobody's used it this semester. And then click Close. There we go. So now that's ready. And then we'll go to our toolbox. We can collapse the spatial statistics tools and expand the spatial analyst tools. And this is the tool set we're going to use a whole bunch going forward, is the interpolation tool set. This is going to be our friend, this tool set, over the next couple weeks.
I'm guessing we're going to need the topo to raster.
Nope, we're going to need the IDW. I'll explain more about what this means, but it's an inverse distance weighted raster surface. So here's the really basic explanation. We'll get deeper into it. In fact, we're going to calculate it ourselves with like a calculator later. And my window's open so that we can all breathe in here. Anyway, so the IDW and all the interpolators do this essentially, is it takes the assumption that Waldo Tobler brought us with the spatial autocorrelation, close things are related, right? And it allows us to do what's a process called spatial estimation, where we say, okay, well, we have a value here. Let's imagine that the value of any given location nearby is related to the value here. Because we know the value here, let's estimate the value at places where we haven't measured them. So in this case, we have z-score values, the cluster values, for each of these locations where we have dots. And what we want to do is visualize it basically as a cloud and not a series of points. Okay, so I'm going to bring in my call hotspot layer. The Z value score, Z value field is going to be the GIZ score. So that's the GEDIS ORD Z score. And remember, that is a statistical measure of clustering. And when it's positive, it means there's high clusters of high values. Where it's negative, there's clusters of low values. And the z-score is a measure of confidence and strength of the phenomenon, is what you might think of it as. And we'll go ahead and use all the defaults. We'll let it choose a cell size, except for the output. Let's put the output as the call hotspot raster dot tiff. Back to rasterland. Woohoo! I love rasters. So call hotspot raster.tiff and click save. We'll just let it do all the rest of the work that we need and click OK.
Oh, jeez.
Now, it looks pretty weird and awful right off the bat, but so we're going to change the way it's we're visualizing it. We can turn off the call hotspot layer and come down to the call hotspot raster.tiff. So open its symbol window, right click, choose properties, go to symbology. And for hot cold, let's use, what colors do you usually use for hot cold?
Red to blue.
Red to blue. Yep. So you want red to blue. So here's the red to blue color scheme. Make sure that the negative numbers are blue and the positive numbers are red. You'll scare people so bad by doing the other way around. And then go to the display tab and change the transparency to whatever, 40, 50%. So this is the color scheme you're after. Red to blue, that one right there.
The thing that
Yep.
confuses me is the other one has a less yellow and green in the middle, but this one is the other finger.
Yeah, that'll work. You just have to invert it. Yep.
So I like this one.
If you like the other one better, that's fine. But you have to, so if you choose the other one, there is another one that's red on the bottom and blue on the top. This one, is that the one? No, where was it?
I can't find either. I was like strokes and burnt.
Down there. So here, this one's red on the bottom, blue on the top. If you want to use it, you can, but you have to click this, right click, where is it? Oh yeah, click right there and choose flip colors.
I see. I just want to know the way to do that.
Yeah, either way works. So you can choose the blue on the bottom one, but if you like the other one better, I'm going to choose the blue on the bottom one. Oh, and I'm flipped already. There we go. Whatever you do, just make sure your negative numbers are blue and that your 0 area is near the middle. And then click OK. Once your display, go to display tab, make sure it's transparent a little bit, and click OK. And so that gives you a sense of your hotspots, and it makes it a little bit easier to view it, to understand what you're looking at.
It's looking a lot of leaving it the other way. These are the hot spots.
Yeah, it happens. I've seen people do that sort of thing. Yeah. So, for instance, showing, I saw somebody once show an entire downtown area as suitable for conservation. That was popular. People really liked that a lot. They were just filled with glee with that. Anyway, so this is often a better way to visualize than the hotspot dots, right? That can be one of the problems with visualizing it with dots like this, is that it implies that the points themselves are the problem, right? And people, like, if you see your house as a red dot on a map, you generally get to be grumpy. And so it's typically better to, it's a phenomenon that geographers call aura. It's typically better to visualize this sort of thing as an aura than it is as a.
It also makes the problem look more realistic because it's
Yes,
There's
yes.
just like a dot. It's like, oh, that doesn't look too bad. I mean, sure, there's a couple bad areas, but nothing. Then you splay it out as a whole door, and it's like, oh, God, this whole
exactly.
area is terrible.
Another way to do it too that will make it a little more diffuse looking is under symbology. If you choose stretched instead of classified, same classification thing. Just make sure that high is red and low is blue. This time, when you're in the stretched type, you have the invert option, which makes inverting a little easier, and then click OK, and that makes it more of a cloud, so it's a little more diffuse.
They're smack down in the middle of it all.
I can't believe I got through the whole thing in the whole class, which is great. So, yeah, so those are the key cluster analysis tools that one typically uses, are the two that I showed you last time. And I will have you use them in your problem set. All right, that's all I have for today, and I will see you guys on Wednesday. We're going to start interpolation, which is so much fun.
You might actually have a projector by then.
Huh?
You might have a projector by then.
I, can only hope.